Thanks very much for your time, colleagues. This is Mike Anthony, and I have on the call with us Tammy Gammon, who's the principal investigator for the NFPA Research Foundation project, and we also have Bob Weinrob from Ohio State University. So this teleconference is set up specifically to determine how much, to the degree to which we can depend upon data that's already available, easily available at feeder breakers, main breakers, maybe downstream power panels, so that we can use to try to get an estimate of what a phase two might look like in the data gathering. And Tammy has prepared for us a PowerPoint. I'm thinking, Tammy, that it's probably best that I let you be the presenter so you can control the discussion. Is that okay?
That's totally fine.
Okay, good. Is there anything I missed in the introduction? Okay.
I don't think so.
All right. So all you have to do is click yes, and it's your show.
Okay. Can you see my screen now?
Yep.
Okay. Okay, since it's just the three of us, I'd rather us have more of a conversation than a presentation here. And Bob, since you're a sponsor, I'd really like to talk to you specifically about, what you're interested in the project. Can you participate, and would you like to participate in phase two?
Okay. I guess what's really got my curiosity is I'm actually having the opposite effects. Because I know, like you were talking about increasing the number of receptacles on the circuit. And I've had issues where everybody's plugging in space heaters and blowing breakers. Everybody seems to plug into the same one.
Oh,
I understand.
Okay. I'm having trouble hearing you very clearly, so maybe you and Mike can help me out. But what I generally hear you're saying is you're concerned about the number of receptacles per branch circuit, and maybe you'd like to increase them as far as from a design standpoint?
No, actually, I don't think we should increase them at all, because I've had issues with people always plugging in space heaters and blowing breakers.
I agree with you totally. I'm very concerned about changing the requirement from 180 VA to 120 VA. And what I was thinking, and I suggested to Mike last week, is that instead of thinking about it at a branch circuit level, you think about it, at a feeder. Well, I think about it as a panel level, about how changing the feeder calculation requirements. It's currently 10 kVA plus 50% the rest. How do you feel about reducing that number, or do you feel like that we should maintain that also?
Truthfully, I'd rather see them maintained, just because what my experiences have been. I have a situation in one. It's a research building. I know we've been talking commercial buildings.
A research building, just by definition, a research building is a commercial building. It makes no sense, but just about everything comes under commercial.
Understood, but when you say commercial, I think more like a business.
Oh, I do too. I agree with you.
What I'm thinking of is where we have research, minus 80-degree freezers. And I have one scenario in one building when the lady that was overseeing this actually went through and taped off receptacles so nobody could plug in multiple minus 80-degree freezers.
Well, one thing I was thinking about this is when I did the research on the different commercial building types, that I think that there are different types of buildings and that perhaps they should have different receptacle requirements. Like, let's just say we have a general commercial, which would include, I don't see why it couldn't include like office and various types of educational buildings, from a teaching standpoint. But data centers and research labs have, I believe generally have higher VA requirements. I know data centers do, but I'm speaking also about research labs. And I think what we're seeing is we get into a very specialized age that everything becomes more specialized, including our receptacle load. So basically what I'm asking you is, do you want to continue, do you think it's important to continue the 180 VA across the board? Do you think we should look at creating separate categories? Should we just look at it from even the feeder perspective about changing the demand factors, or should we look at changing about branch circuit and feeder requirements?
Based on my experiences over the years, I've seen them convert, like stores into laundromats. They both converted stores to shops, where they put in every equipment. So I'm kind of leaning to keeping the 180 myself.
Okay, I definitely understand that, and that's kind of where I feel too. I mean, but I'm doing the research and I'm recording it. I don't have an opinion about what's right. I don't have that design experience, but I've told other people my background is electrical safety, and I have spent probably the past 25 years being involved in some way or other of fires of electrical origin. And a good number of these fires started out basically at a branch circuit with a fairly innocuous load, like, a lighting fixture or a fan, or just, I'm talking about the hardwired kinds of fans, or just a receptacle load, or just some sort of very low power device. And I understand your concerns, and so this project has kind of opened my mind, but at the same time, I don't feel like I would be the first person to say, well, I think we should reduce from 180 to 120, because unlike other loads that are fixed loads, like when you're hardwiring something in, you know what the load is going to be, but for a receptacle load, you don't know. The load could require 1,500 watts, and you know yourself, you cannot plug in too many 1,500 watt loads on one branch circuit.
No, you can't.
No, I mean, obviously you can't like load up one branch circuit. You'll have your breaker tripping in just a few seconds.
Yep. So,
right.
You're right to identify the per circuit outlet, not the branch circuit requirement when you scale back to the 20 amp or 15 amp breaker. You've got an 80% factor. It was a 1080 watts, and what you end up doing is that we've identified the 180 as a parameter that everybody understands, but really what it amounts to is what is the capacity of what is the diversity of load on individual 20 amp circuit breakers. Without a doubt, and we have plenty of that going on at the University of Michigan and elsewhere, that you'll have a space heater or even an air conditioner, and that does take it out. Does that happen? That happens in maybe 5% of the time. So we've come up with some other ideas. I thought that the idea of maybe having demand factor but ultimately, I think we're trying to focus on the data. How we hope we would get more attendants to tell us, for example, Bob, would you be able to provide data from the feeder breakers on your substation? That's something you're able to do.
No, to the best of my knowledge, our substations don't have we got a demand meter at the, I'm sorry, not a demand, you got your regular watt-hour meter. So we don't have anything individually metered.
Okay, so when you buy a new substation, you're not specifying the feeder breakers with metering?
Correct, not at the present time.
Okay. All right, some do. Some do. In fact, there's actually some codes, I'm sure, that are trying to do that, or make that at least as a recommendation. Didn't we talk about that last time, Tammy?
We did. ASHRAE and IECC and the California Energy Conservation Code, they all, actually, I'm sorry, IECC might not, but ASHRAE and the California Energy Conservation Code have requirements for disaggregation of loads so that they can be easily metered. It doesn't require, from what I understand, you actually have to install a permanent meter, but that you can easily come by and take a measurement.
Yeah, well, on a substation feeder breaker, that's kind of hard to do. Maybe downstream. Okay. All right, so it sounds to me like that you have more of a presentation here, Tammy. If you wanted to go ahead with it, with just Bob, I'll just say I didn't get any response from anybody else. We've done our due diligence here. We did give them a chance to give us an idea of what, if they're able to give us more data that would be easy for us to get. And if we can't get it voluntarily, I have to tell you, we're likely to get it voluntarily, but we just kind of have to bother people. Then
Yeah,
we,
that's what I was going to suggest, is that you're probably going to have to solicit more than just open invitation.
right. For the one or two, for the maybe the half page or page on this call is here to try to get an estimate about what it might mean. We can probably stay conclusive that we're going to have to be a little more aggressive. That would have to be part of the project budget. It would require some man hours to hunt around for. But at least we now know, at least we did try to get an estimate of how easy the low-hanging fruit would be. That's the purpose of this meeting. So, Bob, are you able to put yourself on mute? It looks like we're getting some background.
Yeah,
I'll try. I'll put you on mute here and let Tammy talk. Go ahead, Tammy.
Okay, well, I'd really rather wait for the slide presentation until our meeting on Tuesday, because I was going to use a lot of these slides again, and since it's just the three of us, I don't think I just don't feel comfortable going over it now. I'd like to ask Bob, if I could, if he has anything else that he would like to talk to about the project and how it's going, and the things that he would like to see as far as in data collection, what he thinks is important, as far as what needs to be metered, because I've been looking into different types of equipment, and the equipment is going to be difficult. I'm guessing it's going to be, depending on what you choose, it could be up to $1,400 per location, and probably the lowest we'll get is like $950 per monitoring specific location within a building. And that's for like about 1,000, we're looking at kilowatt hours and kilowatts. That's not even current and voltage, and we're not even getting timestamps with that. But what it will do, these are EMON devices. We can store the data for 72 days, and then it just downloads in a FIFO, a file in, file out format. So I'm assuming it's not even time-stamped. And I'm just giving you my first cut of understanding, because I was trying to provide something to the project when the project moves to phase 2. Better metering options would be like with a GE EPM 4600. And what you can do there is you can monitor basically at the main switchboard at the feeder level. And for you can monitor 6 feeders, and that would be about 6,200. You can also choose the 8 feeder option, so I'm guessing at a couple thousand. But then each set of current transformers for each feeder is going to be about $225. And so, I mean, we're looking at about $1,300 per monitoring location as far as per feeder. With that, we can record current, voltage, power, and I think, we'll have reactive power and power factor. But then again, we're also going to have more overhead for data collection. We can store, I think, the kilowatts and kilowatt hours again for probably about 2 months. But as far as collecting all the other information, then we're going to have to connect it to a computer system, which can record all of the other data in real time. Basically, the other idea I had for a low-cost option would be, there's this company that manufactures data loggers, and it's called, I believe, Onset. And they also have the energy and power loggers, and I'll have to go back and look at the details, but I don't think we're going to be much cheaper. And as far as if we're going to go look at a reputable company, I think it's better off if we go to reputable energy meters as far as using EMON or GE. But the thing is, I think what we could do is we could probably monitor current only for about $500 per location. And I thought that might be something to think about, because that does give you loading information. And we can store it for, I don't know how long. I'm guessing probably even maybe 6 months. I'll have to look at the different sizes of the memory capabilities of the loggers. But I thought that might be something to think about, and I was wondering, what you thought as far as what we need to collect specifically. I think that collecting and storing currents and voltage is going to be, for long periods, is going to be hard to come by unless we can do it at a main feeder off a switchboard, like I was telling you with the GE EPM 4600.
Well, I will say I know that there is lots of. I think what you're describing is a situation in which we don't feel like we have enough. We're gonna hunt down this data. I know it's out there. We'll get it, but we're still probably going to have some deficiencies in assembling the statistically significant data set, as Bob likes to refer to it. So I think as part of the phase 2, you're talking about wanting to actually purchase equipment, and you've just given us a span of possibilities. Do I understand that correctly?
I'm sorry, you just broke up in your last statement.
You've just given us this. This is you're giving an estimate of how we might economically get the current data.
Well, I don't know about economically. The onset is as economical as we're going to get, but I'm just trying to give you a range of options if the sites don't provide the data themselves.
Yeah.
Because I've had a couple of different people related to the project tell me that they do quite a bit of sub-metering, even more than they care to.
Yeah, it's generally they're driven to do that because of energy codes or perception that the information would actually change behavior. And I have not seen many results from more information. People are going to consume the data they want. That much said, Bob, what drives this is that even though you may have one space heater that keeps opening up a 20 amp breaker, say in one of those offices over here at Ohio State, even though that may occur to you, there's still a 300 kVA transformer in the electrical closet, and that thing has 3 kilowatts on it. And it has 3 kilowatts on it because the National Electrical Code requires that it be specified at 300 kVA.
Correct.
So, I mean, that's a problem. So there are some ideas. Actually, the Canadians, and I like to get some, do a better job of getting the website so we can see this project proceed. But the Canadians actually have put something in there, phrase in their electrical code, which simply allows you to, if you have measurements, you can specify your transformers based on measurements of similar facilities. There is something like that in the National Electrical Code, but it's not as general. So there's that possibility. The other is that, and I like the idea of actually putting demand factors on the 180. I like that. Maybe in some cases, if you're going to have a space heater, maybe that maybe we aren't talking about outlets, or we get more granular about if we know that a branch circuit is not going to be having space heaters put on it. There's some other ways of crafting the code to give the designer more flexibility. Those are just some ideas. I don't want to take more of your time, any more of your talk anymore. Is there anything else, Tammy? Because it sounds to me like you'd like to, we're pretty well closed out. We did our due diligence here to see how much early information we can get on data. Probably we need to now go to the regular project meeting next week and give them these findings. Do I understand that? Is that helpful?
Yes, that sounds good. I just want to ask Bob if there's anything else he would like to discuss with me so I can try to include or address or be aware of as I'm finishing up my aspect of phase 1.
There's one thing I'd like to consider, but I don't really think it's within the scope of this project. I like the actual idea of metering, at the panel boards. It can give you a handle on how much your load is actually on there. There is an article in the NEC that says if you have the demand You multiply it by 125% and then make those numbers round up. Say you had 150 amp main on the break on the panel, you got 100 amp demand, you would still be allowed to add 25 amps to it. It gives you a better handle on what's going on. Because I know that problem pops up with panel boards for generators that are feeding emergency loads. But I don't know, that's really not in this scope if I read everything right.
Okay, I'm having a hard time. Mike, can you hear Bob clearly?
I cannot actually, and I've had to mute you, Bob, so we could hear Tammy. Maybe
Okay, well, go ahead, Mike.
if you call in on next week, where we hopefully it'll be a larger crowd. At least that's the formal NFPA meeting. Actually, that's going to be it's a telephone conference, isn't it? It's not a webinar. It's not. There won't be any visuals. That's Casey's, and it's all audio. Is that correct?
That's correct.
Yeah.
We'll circulate the PDFs in advance.
Okay.
I think if I had the idea of what you're saying, Bob, is that you're addressing the 125% requirement for a lot of loads when for perhaps continuous loads on panels.
Correct.
Okay. And I've noticed that, okay, we have a lighting load and it might be, let's just say, 10 kVA, but the demand load is always like 12.5 kVA. And I'm glad you brought this up. And I hope you can we can communicate, because this has been something that has really been bugging me. Is the one thing that I think that Mike is very concerned about, and I understand his concern totally, is that the transformers are being oversized because of inflated load requirements, however you look at it. And one thing I truly do not understand is if we have a 10 kVA connected lighting load, that we have to have a 12.5 kVA demand load, because the lighting load is fixed and it's not going to change. I do understand, of course, that the wiring has to be appropriately sized, and our overcurrent protective device has to be appropriately sized. But beyond that, we're building an extra 25% right there, and I don't know why we have to do that. And I wish I could have heard you more clearly to hear specifically what you had to say about this.
I was talking about the band on a little differently, like you're metering your main service into an into a building, and say you got a 500 kVA transformer feeding it. But if you only have a 300 kVA demand, you're allowed to multiply that by 1.25. So I think in that case it would be 375, and you would still be allowed to add 125 kVA to that service.
Darn it, I'm sorry. I can't hear you.
I'm sorry.
I mean, I can hear the words, but I can't hear them clearly. I hear you saying 375, and I just don't hear the whole conversation clear.
Okay. Well, suffice to say, to help answer the question, it always comes up, and it's one that I spent a large part. I want to take the screen over. You don't mind if I take the screen over again here, Tammy, so we can close out?
Not at all.
Okay, let me find it here. So I will make myself the presenter. And then I'm going to move and let you see how I've been trying to reckon with that problem. Let's see. Let's find it over here. Are you able to see? Let's show my screen. There we go. Okay.
Yes, I can see your screen.
Okay. Bob, can you see my screen?
Yes, I can.
Okay. All right. So what I'm trying to do is I've collaborated with a colleague in Italy, and he's the knowledgeable one about the scientific basis for the European methods of sizing and designing wires. And continually we run into the Europeans are always asking us, why are you oversizing your feeder breakers, your feeder circuits, and it has to go. I think it has its origin in the fire safety preoccupation of NFPA, and I do get that. That's how the whole history of the NFPA. But if you look at the way that the Europeans, we had to start. I apologize, but this is a paper that will be published in the next fall. And here we try to get to the whole pathology of why, comparing the way the IEC approaches circuit design to the way the United States approaches feeder circuit design. It's an enormous problem. This is my markup, as you can see. So I guess to cut to the chase, the United States system in most cases have oversized their building internal circuits for a very long time, leaving a lot of material on the table. And if we're going to be serious about energy conservation and such, I'm only asking the question, and again, starting from the academics, making sure we got our science right, what can we do what changes in the National Electrical Code do we need to make so that we can be safe, but also not waste materials? And at the moment, the waste is fairly significant. So with that much said, that's somewhere up on our website. I don't want to bore you with all that stuff, but is there anything else? Bob, just be aware that we'll be meeting again online. If you like this, obviously this will be recorded. We put it up there because not everybody. Sometimes, we get fair attendance on these. People can't always make the meeting. Everybody's got all kinds of meetings. So we had this this was last week or so, or a week or two ago. 13 people have been able to use this that couldn't use it before. So if you can't make next week's meeting, Bob, you can see what's happening here. And in general, we're very grateful to have Ohio State's interest here. I can't, thank you for your time. You are a project sponsor, and we hope Tammy's trying to be very attentive to all the needs of the project sponsors.
I'd just like to thank you for calling in, Bob. I've enjoyed communication with everybody involved because I learned through it all, and I just try to make my part of the project better from it.
Thank you for everything you're doing for us.
Okay, so I'll close the call, and this recording will be up on the meeting webpage. Thanks very much, Bob. Thanks, Tammy. I'll see you next week.
Thank you.
Okay, bye-bye.
Everybody have a great weekend.
Bye-bye.
Bye.